Hey guys, welcome back to Algebra 2. Today we're talking about classifying polynomials. We're starting chapter 5 today. So we're going to be looking at different graphs of lots of different degrees and studying their behavior and classifying them and things and such. So our objective is to classify polynomials and look at the graph polynomial functions and describe the end behavior. So you're going to want to write this down. Because you're going to refer back to it whenever we're classifying polynomials. We classify by the degree and the number of terms. Okay, so it's important that it is written in standard form. So what that means is your exponents decrease in order. So like 3, 2, 1, 0. Okay, it has to be written in standard form in order to do this. So 3, 2, 1, 0. So after it's written in standard form, we look at our highest exponent, and that tells us our degree. So this degree is a 3, so it is a cubic. Okay? So if our highest exponent is a 3, it's a cubic. If our highest exponent is a 2, it's a quadratic, which is what we talked about in chapter 2. Remember, little 2 makes a u, chapter 2 in ingenuity. Then we look at the number of terms. So we have 1, 2, 3, 4. We have 4 terms. So 4 or more terms is considered a polynomial. So if you have just 1 term, it's a monomial. 2 terms, it's a binomial like a bicycle. 3 terms is a trinomial like a tricycle, bicycle with 3 wheels, or like a triathlon with 3 events. 4 or more is just a binomial, or sorry, a polynomial, which means many terms. Poly means many. And the term is divided up by an addition or a subtraction sign. So let's practice classifying some polynomials. So first we have to write in standard form. Remember, decreasing order of exponents. And then what's the classification of each by degree and the number of terms. So we're looking for 2 words here. Degree, whatever that is, and then however many terms. Okay? But in order to do it, we have to write it in standard form, so our exponents are in descending order. So look at for our highest exponent, which is the 2. So we're going to write 9x squared, cancel. The next exponent is a 1, so that would be 3x, so plus 3x, cancel. Then we have our constant plus 5. So to classify it, we look at our degree. So our highest degree is a 2, so that means it's a quadratic. Okay, and then we count our terms, 1, 2, 3, 3 terms, so it's a trinomial. Trinomial. Okay, now let's look at B. We have 4x minus 6x squared plus x to the 4 plus 10x squared minus 12. Okay, we need to write in standard form, so look for our highest exponent, which is the 4. So x to the 4th. Now we look, is there a 3? Nope. Is there a 2? Well, there happens to be 2 2's. Negative 6 plus 10 is a 4, so plus 4x squared. Nope, nope. Okay, now our x, 4x plus 4x, and then our constant minus 12. Okay, now it is in standard form, so we can look at our highest exponent. Our biggest degree is a 4, so that is a quartic, and I always remember quartic. I always remember this by a quarter, like you have 4 quarters and a dollar, so quartic. And then we have 1, 2, 3, 4 terms, so that is called a polynomial. Okay, so that is how we classify by number of terms and the highest degree. Okay, now let's talk about end behaviors. So this is another graph that I would write down, another chart that we're going to be referring back to. So when it is in standard form, we're going to be looking at the leading term. So this is represented by a x to the nth power. A is your leading coefficient, and n is your highest degree. So that tells us a lot about our graph. So if a is positive, that means our n value is up and our n value is up. Okay? If it's even, they both end up, and then if it's odd, they're opposite, so it starts down and ends up. Okay, if A is negative, we know, like with quadratics, it ends down on both. If they're even, they're both starting and ending down, and if it's odd, it's opposite, up and down. Okay, so let's kind of look at some graphs. So here we have 4x to the fourth plus 6x cubed minus x. We don't really care about the second part. All we care about is this leading term, which is 4x to the fourth power. So our 4 is our a, our other 4 is our n. So 4 is a positive number. So since 4, our a is positive, it's either going to be up and up or down and up. So notice that these are the same. So that means we know it's going to end up. Okay, since 4 is an even number, they start and end the same. So that's why it ends up and up. Okay, let's look here. We have y equals negative x squared plus 2x. Again, we don't care about this plus 2x. All we care about is our leading term of negative x squared. A is a negative number, so it's either going to be down and down or up and down. So A is negative and it ends down right there. Since 2 is an even number, it starts and ends the same direction, so it'll be down and down. So down and down. This one was up and up. This one is down and down. Okay, y x to the third power. Okay, we have our invisible 1 here, so 1 is positive, so that means it's going to end up. 3 is an odd number, so it's going to be down, so it's going to be down and up, down and up, down and up. And then lastly, we have y equals negative x to the third power plus 2x. Our leading term is this negative x to the third power. Okay, a is negative, so it means it's going to end down. 3 is odd, so they're going to be opposite, so it is up and then down. Okay, so let's look at some without the graph being provided for us. And a great way to check this is in Desmos, okay? I know Mr. Thomas and I, we keep saying use Desmos, use Desmos. Seriously, use Desmos, okay? Always check your answer there. So here's our graph that we're going to be referring back to. So we're describing the end of the behavior. So it's either going to be up and up, down and up and down, down, okay? So consider the leading term. So right here, it's 4x cubed. What is the end behavior of the graph? And then we're going to check it in our graphic calculator or in Desmos, okay? So here, our a is a positive number, and our leading degree, our n, is an odd number. So since a is positive, it ends up. 3 is an odd number, so it's opposite. Okay, so it's going to be down and up. Okay, another way you can just kind of look here. A is positive, and n is odd, so it's going to be down and up. Okay, and then let's look at this one, and then we'll check them in Desmos. So we have our leading coefficient, negative 2x to the fourth, and double check, we have 4, 3, 2, and then 0, so we're good there as far as in standard form. So our leading term, our a is a negative, so it's going to end down. Let me throw off the arrow, sorry. It's going to end down, and then 4 is even, so it starts and end the same, so it's going to be down and down. Okay, so we can always, let me go backwards, and we are going to exit. Okay, so sorry. So if we look at this one, we said it was down and up. So if we go to our graphing calculator, our Desmos, it's down and up. So it goes down and then it ends up. Okay, and the next one we said was down and down. So it's down here and down there. Okay, so use Desmos. It's a resource out there, and let us know if you have any questions.